All right. Welcome to our brief introduction on our new unit. We're going to be studying parabolas. Okay, parabola is also called a quadratic, but a parabola is the shape of the quadratic. So why are we doing this? What are we going, why did we just do exponents and what is next? So what we're going to do now that we studied a unit on exponents and polynomials is we're going to start learning how to graph exponents and polynomials on a coordinate system. So the parabola is a graph, and it's also known as a quadratic. Okay, if you remember the quadratics, when we just learned all the terms, the quadratic meant to the second power, right? Remember that? So it meant to the second power. So that means we are going to learn this entire unit how to graph functions that have x to the second power x squared. So that is all we're going to focus on. So the shape of this is called a parabola. So first what we're going to do is we're going to try to discover, well, what is a parabola? What's the shape? And then what are its parts? So I'm going to go old school on you real quick. And we're going to make a t-chart. Remember back in the day when you first learned how to graph lines and you did t-charts, and you did a t-chart from 2 to -2, and then we plotted it. So we're going to do that on this graph, and then I'm going to have Desmos do it for me just to show you that I'm not crazy, but I am. But that this is true, and this is the shape of a quadratic. So let's plug these numbers in. I'm going to start with 0 because that's the easiest one to plug in. If you plug in 0 into x, 0 squared is just 0. If we plug in 1 to x, 1 squared, 1 times 1 is just 1. If I plug in 2 into my x, 2 squared, 2 times 2 is 4. Great. All right, now let's plug in a negative. So here's where some of us got a little bit tripped up when we studied exponents last unit. When we plug them in, we need to make sure that we have the negative in the calculator like this, because otherwise we're not squaring the negative. The calculator's not doing it. But we know in our heads, we're going to do -1 times -1, which gives me a +1. And then if I plug in -2, so -2 to the second power would be -2 times -2, and that gives me a +4. So look at this t-chart. It's reflecting. So the 2 and -2 have the same value, and the 1 and the 1, or the 1 and the -1 have the same value. So it's very, very similar to an absolute value function, because the negatives are positives, the positives are negatives, right? So it looks the same. Well, it looks the same, but does it look the same? So let's plot it. So 0, 0, 1, 1, 1, -1. Okay, so it kind of looks like a V so far. Now I'm going to go 2. Oops, sorry. I got to go this way. We went by 2. Ignore those dots. Okay, now we're going to go 2, 4. So 2, 4 is all the way up here, and -2, 4 is all the way up here. Okay, so if I graph this, here we go. Look what's happening. It's not a V anymore, but it's a U. So let me put this in decimal so you can see. Okay, so look at that. That is our parabola. Okay, so it is very, very, very similar to an absolute value to a V, but the difference is that it's not a V, it's a U. So we're curving. So the squared, the exponent makes it curve because it makes it go up faster. It's not going at a constant rate of a slope anymore. We're going up faster, exponentially, hence the exponent. Okay. So just so you understand why and where that is coming from. So now all we're going to do for this lesson, now that we understand what it looks like and why, is we're going to analyze it. So remember those 6 vocabulary words that we did with the absolute value? We're just going to do that with this. So I'm going to go through with you to refresh your memory on those 6 vocab words. So the first one, if you remember, was identifying the vertex. So on your homework, you'll see that you have pictures already. You're not going to have to graph yet. You're just going to have a picture and identify the vertex. So let's identify this vertex. So my vertex here is at 0, 0. Okay, so remember that I want it in a coordinate form. So your vertex here is 0, 0. So again, I'm just going through examples here. So you can just watch. If you want to write them down, that's absolutely fine. But just so you remember what these vocab words mean. Okay, the next thing that they'll ask you is, does the vertex represent a minimum or a maximum of this parabola? So in this case, it represents a minimum. So your vertex is a minimum because it's the lowest point on your graph. So we're going to write minimum here, or just write min. Okay. Now the next thing would be the axis of symmetry. So remember, axis of symmetry is what cuts it in half. It's a line, so you need to write x equals. So my axis of symmetry is right down the middle at 0. So x equals 0 is my axis of symmetry for this parabola. Next would be the domain and range. So the domain is going to be the exact same as the other one, all real numbers. And then the range is also going to be very similar, where we make an inequality. So if you remember with the range, it represents all of the y values of this function. So how high or how low does this graph go? And so this graph, if you notice, it's going to infinity up here, but it starts at 0. So it starts, the lowest y value will be 0. So that means that all the y values must be greater than or equal to 0. Okay, then the last ones were the x-intercepts and the y-intercepts. So I'm going to go with the y or the x-intercept first. So your x-intercept is where it crosses the x-axis, and it crosses just one time, and that is at 0. So 0, 0 is the x-intercept. Now, I want to also get you familiar with these words that they're going to use. So besides x-intercept, they're going to use the words zeros, or the solutions, or the roots. There's actually 3 different words that they might use. I would definitely write that down. So if you see this on your homework or moving forward, if they say find the zeros of the parabola, find the roots of the parabola, find the solutions, this will all make sense because we're going to be studying parabolas for a very long time, and all the different ways that we can find solutions, all these will make sense eventually. And then the last thing is the y-intercept. Okay, so the y-intercept is going to be at, let's see, 0, 0. Okay, so I'm just going to go through one more example with you, identifying all the parts, just so you have one more thing that you can refer to if you need help. But this is all we're doing today for homework, is just looking at the different parabola graphs and identifying all of the parts. Okay, so let me clear this out. And I'm going to put in a new graph. So I do not expect that you know how to graph this at all. And we're not going to worry about that. That'll be what we focus on later. So I'm just going to put in, this is going to be negative x squared minus 2x plus 8. Let me zoom in a little bit. Okay, so first of all, I want you to just notice how it flipped upside down. So same thing, hopefully you're thinking to yourself, why would this have flipped upside down? Look at what's in front of the x squared. Same thing as the absolute value function. There's a negative. So the negatives made the v's flip upside down. So the negative is going to make the parabola flip upside down. So now I'm going to do is just go through with you one more time how to do the different vocabulary words. So the vertex here will identify, here's my vertex. So that's at -1 and 9. So -1, 9 would be my vertex. And then we're going to ask ourselves, is this vertex a maximum or a minimum? And in this case, it would be a maximum because it is the maximum height or the maximum point in my graph. So this vertex is a maximum. Okay, next, the axis of symmetry. So axis of symmetry, this time, remember, it is where the x value that cuts the graph in half. So here is where it cuts the graph in half, and that's at x equals -1. Next, the domain. Remember, the domain means all of the x values. Well, I can plug in any x value. It's going on. You can go anywhere left to right. So your domain is all real numbers. Same as the absolute value function. Okay, next is your range. So remember, the range means how high to how low does it go. So it goes down forever and ever and ever. It goes low forever, but it doesn't go high. It stops here at y equals 9. So that means that our range are all the values of y that are less than or equal to 9. All right, lastly, your x-intercepts. Remember, the x-intercepts could be the roots, the solutions, or the zeros. So your x-intercepts, this time we have 2 right here, where it's crossing the x-axis. So these two solutions would be -4, 0, and looks like 2. Yep, and 2, 0. Okay, and then last but not least, our y-intercept. Remember, the y-intercept is where it crosses the y-axis. And so in this case, you're always going to just have one y-intercept right here. That's where it crosses the y-axis. So that's at 5, 6, 7, 8. So it is at 0, 8. Okay, so just to reiterate this is something we may not have caught on to in the last unit. Just to reiterate the difference here, you will always have one y-intercept. You will always have one. Okay, you always, always, always have one. But the x-intercept, you have 3 options. Either you have one solution, or it crosses one time, which we just saw. You could have 2 solutions, which this is an example right here, because it crosses 2 times. Or you could have no solutions. And what did that look like? Do you remember what that looked like? That meant that it didn't cross the x-axis at all. So it might have been over here, like this, or it could have been down here, like this. Okay, so those are your options for the x-intercepts. Okay, so now you're going to go ahead and do your practice problems on your worksheet and let me know if you have any questions. Good luck.